All right. Hello, everybody. Welcome. Those of you that were able to make it on time, thank you. And if you're watching this video later, you have failed. No, I'm joking. You've done great. If you're staying on it, even on the videos, I understand this isn't the perfect time for everybody. And keep in mind that this is a practice that you got to get into, right? Don't just do it on the times that we have classes. Don't just do it an hour and a half. Do it as much as you can. Try to fit in 10, 15 minutes a day. Do something, work through some problems, practice the stuff we did from weeks two and one and two, and keep building like we are. If you're copying and pasting the files, that's totally fine. It's most important to understand the concepts, where things go, how they fit together, and reach out with questions. And we are in week 5 of 6, so we're almost done. We're moving from the front end that we built last week into back end design and development this week. Specifically, we're going to start by talking about databases and CRUD operations. I know some folks in this group know databases really well. We're not going to get really deep into it, but we have to understand some basics of it to understand how to interact with it from a web application standpoint. And the things that we're going to talk about here, again, they apply to the design of any system that's going to include storing data of any kind. So with that, before we move too much further into things, any questions on anything we've covered up to now? Anybody have something that they've really wanted to bring up that they haven't? All right, cool. Remember, keep those questions coming as you have them, but let's dive into the theoretical stuff we have. We have a few more slides today than we've had in the past, but it shouldn't be a ton, and we'll get hands-on later with implementing this to make it all a lot clearer on what we do as we go through this. So first, let's talk about databases, what they are, how we're going to interact with them, sort of the major points about them. So we talked about data a couple of times, right? So data, the first time we talked about it was in the way computers understand and store information in a series of bits arranged in 8 of them as bytes. So this is sort of the low level, the first way that we talked about data. Then we talked about data types in Python, where we had our literal types, if you remember the things that we wrote directly in, like strings, integers, floats, our Boolean values. And then the sort of different collections of things where variables can be a named space in memory that can hold one of these other types of data. There could be lists that can hold other types of data, tuples, sets, dictionaries. And then we talked about things that add functionality, which really literally just functions. It's just about it. This is where we do most of our work for algorithms, where we've been doing the handling of HTTP in the context of our Django framework. We're going to do more of that in the backend stuff, but the functions are the things we've been using so far. And then the grouping of all this together, the functionality and data in classes. That's a really powerful thing in Python that we've talked about the structure of, played around with at a real basic level. We're going to use it in a context today and show one of the cool things that it can do. But to refresh your memory on the structure of that, the attributes are similar to variables, but they're inside of classes. So classes have attributes and they have methods. Methods are similar to functions, but once again, they're inside of classes. So this is the other way we've talked about data so far, or one of the other ways we've talked about data so far, as ones and zeros in binary, data types in Python. And today we also talked about data structures. We're going to skip over that because that's not hyper relevant to the distinction here. We could lump that in with the data types. But today we're going to talk about data in databases. And when we talk about that, we mean information that's used for an application. So we want to talk about dates, times, usually some kind of customer information, names, addresses, that kind of stuff, right? So customer details, this could be audio, video type stuff. Any of the broader sort of information when we talk about data in a database, that's what we're talking about. It could be streaming information. This could be real time, all sorts of different stuff. So major types of databases. This is not going to be an exhaustive list, but we are going to be using one particular variety, the relational database. We're going to talk about its structure, how it's laid out, how to interact with it. The thing to remember is that it's going to use a structured query language, or SQL, SQL, as I like to refer to it, as I think a lot of people do. And I know some folks, again, are well-versed in this. We're not going to get very deep. We're not going to write our own SQL, but we need to understand how our Django, our Python, is going to interact with this, and we need to picture the interactions that are happening. And we design an application, we're going to design it at a very low level with the database structure and queries in mind. So there's another broad category of databases that could be used. The relational database is very, very, very popular. It's out there. It's all over the place. It's not the newest. It's one of the older ways of doing it, but it's absolutely solid and it's totally good way to go. But there are plenty of options out there that are not what they call SQL at all. So no SQL types of databases that do not use structured query language. They could be object oriented. They could be document oriented. They could be things that have key value. Whoop, all these other sorts of structures. And the point here being that you don't have to use a relational database. It's very good to use. It comes standard with Django. That's one of the reasons we're going to use it, because we're not going to change the database. It's easy to move from what we have now as a sort of testing database, the SQLite 3 that we showed, SQLite 3 that we showed in our structure. We'll look at again when we go back to our consoles. That comes standard for development. But if you want to move over from the project that we're doing now to a production level database, it'll be very simple to use something like MySQL or Postgres. Even those are both structured or relational databases based that SQL can be used to access the information out of in the way that we're going to talk about today. But again, you don't have to. There's plenty of other options out there. And this is somewhat of a false dichotomy, because all these things under NoSQL are not really related to each other in many, I guess, I don't know, relevant ways outside of the fact that they don't use SQL to access them. But we're going to be using a relational database. We're going to talk about that more. We're going to talk about what it is and the details of that. So relational databases. They have some key concepts that we want to talk about. The first is that they're broken down into tables. There are tables in a relational database. You could think of this as rows across one side, and each row contains one record. It's uniquely identified by this idea of a primary key. This is going to come up a couple of times later. So it's something that makes that row a unique row out of all the other rows in the table. And there are columns that say what the attributes of the thing are, right? So it'll be like a name, an address, whatever the case may be, across the top row, and then all the rows beneath it will be unique rows of data. It might look like a spread. You might be thinking, oh, it looks like a spreadsheet. Databases are not spreadsheets. So decouple that in your head a little bit. But for getting started, you can picture that row column thing in a similar way as a spreadsheet. It's not really a spreadsheet. And one of the things that makes it different is this process of normalization. I want to talk about this a little bit without getting too deep into it. So anybody that knows normalizing, we're not going to do any real depth in it. But I'll see if anybody has any questions up to now before I hop out of this slide and go to this normalized example. Questions or comments about what we're talking about up to now? All right. Cool. So who here actually, I know, so we got some folks that work with databases and SQL professionally. Who here knows what I'm talking about, normalizing data? Who here has an explanation of what that is or has heard that term before? Anybody?
Like when you clean it up, is that what you're referring to?
Yeah. That's this. It's like the process by which you change your data structure to be more readable, resilient to changes, that sort of thing. So yeah, clean it up is kind of one way of thinking about it. So let's look into this as an example. And I'm going to use this Wikipedia article for a lot of reasons. First of all, I think Wikipedia is awesome. Second of all, I was going to come up with my own couple of steps, like come up with a fake data set, say, okay, this is one way, this is the first part of normalizing and so forth. But then I found this when I was doing my research, and it turns out that this is an article written by, largely a self-taught guy. And also, you all know some HTTP now. You can, or some HTML. You can hop in here and make changes to the Wikipedia page if you decided that you know this stuff better than he does. So I encourage you to do that. But the layout of this example is really useful, and it has over here an actual walkthrough of this entire process of normalization. So I just want to use this as a quick example of what it is. We'll step through it real quick, why we want to do it, and then we'll go back to our own context of it. So here there's a example of it, what the objective is. Really the idea here that we want to capture is that this is sort of an old way of doing it. It came around the 70s, early 70s. And the idea is that we want to make this resilient to changes so that things like insertion, update, and deletion don't break your database. And the information that comes out of it is reliable. You know that you could trust it. And there are some specific anomalies that this is trying to solve, right? So if you want to come in, I encourage you to come in here and look at exactly what it is this is trying to prevent from happening. There's this update anomaly, delete anomaly, and so forth. But when we talk about normalization, we talk about things being in normal forms. And so what you do is you take a set of data that could be, let's imagine it in a spreadsheet. Imagine you have data written down in a spreadsheet. And it's just been saved however it's been saved. Like it's at a bookstore and people have been just keeping information in spreadsheets about their inventory. And what you need to do as a developer is normalize it for a database use. The idea is to take that spreadsheet and put it into a format that's going to be resilient to changes, easy to read for humans, and easy to read for machines. That's really the goal of normalizing, right? So it's going to make it look a little weird, but it'll be something that should be intuitive to a sense, but speed up the processes by which you're going to be accessing and doing this. So we're not going to step through all of this, but you can see there's very specific ways that you go through each normal form. So there's the first normal form, and then you move on. You have to meet these criteria and constraints over here on the left. And I want to step through just a couple of the first two to show what this process is, and then we'll show it in context. And so down here, the example of step-by-step normalization is what we're going to do. And he has this, explanation of what's going on here, what the process is, how we go through here. We're going to start down with the initial data set. So this is what I'm saying we should picture as being a spreadsheet at somebody's bookstore. So you see these got the row across the top that's got the headers, and then there's a title of a book. And then we look at this, there's, subject is stacked up. So the first thing we want to do is we want to break out that piece. You can't have tables inside of tables. You're like, all right, well, let's just break this out so we got at least the subject information someplace separate of our title information, like the way it is here. And so when we do this first normal form, we have each field is going to contain a single value, right? So there's no more of that stacked up values. And what we've done is we've broken out, there's now a book table and a title subject table. And the idea here is the title is unique enough to use this. This is a good key for this. And then this combination of title and subject is going to be unique in this table. So now instead of having these three subject values jammed into one row to make it difficult to pull out or read, it's now in two separate tables. So if you want to find the subject information, or if you want to find what titles include MySQL, for example, or the subject is databases, you'll find this title associated with it using this table. And then using that title, you can look up the book to find what other information you need. And that's one form of normalizing. Is that making sense? But got questions about that so far? On why we would have done this step and what we're trying to get to?
How often do they run a normalizing task on a database?
That is a great question. So this is generally something that you would want to do very well at the design phase. You don't want to be doing a lot of these changes once you have your database up and running. So this is a design phase step. And we'll get into that. This is definitely something you want to measure like a bunch of times before you cut. You don't want to make changes down the road once you actually have data in these things. Does that answer your question?
Yes, sir. Thank you.
Yeah, absolutely. So then, we're not going to roll through all of this, but I do want to kind of show a few more examples. This second normal form step is a pretty good one. So this is resolving a composite key where we have two or more attributes in the thing to use to identify. And so what we want to do is try to avoid that. And if you look at this set of data, it's very similar, but we have two titles that are the same. So we got the two here on the top rows, and then another two down here that are the same. So it's 4 rows, but it's really 2 books in four rows, in 4 records. You see that those formats might be different. So we got ebook, hardback, and paperback, and the price is different depending on that format. But other than that, it's exactly the same. All the other columns here, if you take a second to look at it, they're exactly the same. The only differences are format, price, and the title. So what we're going to do is we're going to break it out again to where we have our book table, and then we have a price table that now contains the title with a format and price, because this row is going to be unique now as this combination of things. With the title, format, and price, there's only one of those in here. And so this is one way of approaching how to make that cleaner, easier to read. And then as you go down with this further, you'll see that it's the original data set we had was really wide and had a lot of columns. And now we're doing more tables that have narrower columns. And we're more specific on what they do. And we're talking about how these things are related to each other, right? There's still a book table in this one. We're not going to go through the steps of the third normal form. But as you can see, we now have a price table, and we have the authors are broken out into something separate. So we have the author here, but now we can have their nationality listed. We can have more details about the author in this. We can have information about the publisher, and up here we have stuff in genre with numbers to link into our genre table and look it up that way. So this continues on in this vein to adjust your data in such a way that it makes it resilient to changes, so things can be updated separately from each other and not be reliant on each other in the way it would be if it was just in one row of information, and easier to read for both humans and machines. Making sense?
So dumb question, but when you're making these tables from the main table, I would suspect that you're writing some SQL scripts to pull certain information
Yes.
to create these simpler readable tables.
Yes, absolutely. And that is the next question. You're like 2 steps ahead of where we're going to go, but I'm going to tie off where SQL comes in
Okay,
just a second. But yes, that's
fine.
absolutely what's going to happen. Is the goal that we have with this, as I mentioned, that we're going to use SQL to access the information out of here and to do things with it, right? All the operations that we can do. This is intended to make that easier and to make that work properly, is to set this up in a way that SQL can access it and humans can read it and maintain it. So yes, absolutely.
Thank you.
Yeah, sure. Cool.
So the
So,
other question I
oh yeah,
have
go for it.
is the very first table you had,
Uh-huh.
that's being pulled either by a script or an interface into another application or
Oh,
function.
that would be a context dependent situation. This is an imaginary scenario where it doesn't really matter where it comes from. But in the context of our design process, I guess what we would do is we'd think about the kind of data that would flow through our application, right? So think about it in the context of design that we've used so far, or the analogies that we use so far, or metaphors, I guess, are probably more appropriate, like building a building, right? We think about the kinds of people that are going to be coming through that building. Is this building a bank? Is it a hospital? Is it a residential area? Same thing with our application. What sort of information is going to come through it? Are we going to have addresses? Are we going to have credit card information? Are we going to have user information? And then how are those pieces of data going to be related to each other? And so you design it with theoretical data in mind based on the information in this top row, like these top pieces right here are the known parts, right? You know the things you want to track, and you decide what information is going to be in your application. And then you do this exercise as you design it. Like, okay, so we're gonna be getting people's first and last names. Do we need to separate those? We keep them together. What do we do with names, right? Are we gonna keep their addresses, or do we have documents that they upload? All that goes into your design for your application, and this normalization process is part of that. Does that make sense?
Yes, thank you.
Sure. And in that same vein, that is seriously like the perfect question. We're gonna go back to our slides real quick, and this I encourage folks to look this up, and not just this as an example. There's probably some better explanations of normalization out there, but back in here, this is an example of what we call a schema. So when you do this process of designing your databases, you're going to come up with something like this, where this is a star schema as an example. This is really commonly used. It's a good example to kind of get going on what schemas are, but it's very viable for a real schema out there. A lot of organizations really use this. They have an actual relational database in a star schema and access it through SQL, which we'll talk about next on how that's done. But this example here shows what's called a fact table here in the center. It says fact underscore sales. It's in blue. And then surrounded by these dimension tables. So we have a dimension table on the left for dates. That's only information about a date. You could have the day, week, month, quarter, whatever. Dimension about a store. So the store's got number, state, whatever else information, and then product down the lower right. The fact table here is a sale, right? Now everything is in plural in the fact table because the idea is that this is a fact. Think about a real life event. When we talk about databases, again, we're talking about real information or information referencing something in the real world, like a name and address, or the fact that a sale happened. So a sale is going to have all these IDs to it, like a date that it happened, a store that it happened in, a product that was bought, and how many units that were sold or bought, however you want to think about it, is going to be the only unique part of this fact table. Everything else, or this fact of this fact of this sale, is going to be the number of units that were sold. All the rest of these things can reference out by ID numbers the date that can reference whatever date that happened, and the store or whatever store it happened in, and the product for whatever product it was. And the idea with this is that as more sales are made and more sales rack up here, the sales table will get much larger. It'll continue to add more records, but the dimension tables around it stay the exact same size. They don't have to move at all. If this was all in one row of information where each sale had to require you had the date, the store, and the product number on it, your database would be like 3 times larger for each record that you added to it because you have to have redundant information in there about the date over and over again for every sale that was made on the same date, right? So this is one of the reasons that you would do this, but you would break it up like we said before on just these names, right? So right here we don't have any real data here. We just have what our column headers would be, the top of that very first row, and then we know we're going to have a record that corresponds to each one of these things for our dimension and fact tables. And then also we can make changes to any of these. If we want to update some information on the store, add different rows to this, do different things to it, it's not going to affect our fact table or our product table. If we add new products, it makes no difference. It's not going to change anything about our stores or our dates. So this is an example, fairly simple, but not that contrived example of why we would want to go through this exercise of normalizing our database and what the end result might look like. Is this making sense? Any questions about this?
All good.
Cool. Then the next piece is how do we get information out of it or do things to that information once we get something out of it? Like, how do we interact with this? That's where SQL, or structured query language, comes in. So a query is just a question that we send to the database, and it has something to do with the way we access it and do something with the data that's in that, right? So we send our query, and our query could be something like how many TVs of a particular brand were sold in a particular year in each country. I picked 1997 to try to keep this data as up to date and relevant as we possibly can. Now, it's because that matches the example I'm going to show here in a second of a SQL statement and show the parts that are relevant to it. It's the example, again, we pulled from the same Wikipedia article. But this is how we would translate that question. How many TVs of each brand were sold in 1997 in each country out of a table like following that star schema that we showed with the sales and the date and the product and all that kind of stuff. The SQL that we would write would look something like this. And we're not going to write any SQL statements ourselves. But I do want to highlight 3 major parts of this because when we write our Python code in Django, we're going to use Python to do this sort of thing. So it's going to interact with SQL in some point, and we're going to be doing some of these steps, and we just good to conceptualize which steps we're doing, right? So the first piece on here is a select statement up here at the top, where it says what we want to take out of, like, what information we want, right? So this has the brands. So when we say each brand, that's what we're looking for. There's some other stuff we could do in there. We don't have to worry about the as and the sum and all that kind of stuff. Skipping down to from, it says fact sales. So there's that fact table in the middle that we're looking for. So it's like select what information from which table, and then where is a set of criteria that we want to match, right? So this has got the date, this has got the product title as TV, and all that sort of stuff. So these are the 3 major parts that I want to highlight here in a SQL query. This is a query that we send to the database. It says select what information from which table where the data meets these criteria. And we're going to take this again. We're going to go into our own Django framework and write in Python something that's going to interact with this. And it's good to think of it in this sense of selecting what information from which table where we meet a certain set of criteria. Any questions on this? Michael, does that answer your question about how this all goes together?
It does. I'm seeing how the flow goes based on the directive that was made with the statement. How many
Yes.
TVs of each brand were sold? The query basically lines up with that.
Right. It is fairly intuitive, yeah. Cool. So that is SQL. The other part, and that's databases. Those are the things we wanted to cover. We're going to make our own databases today. We'll not make our own database, but set up our own database tables that are in a SQL database, right? And it's going to boil down at some point to SQL. That's what Django is going to do for us, is that interaction. The other piece that we're going to work on today and start this week and as we go, the back-end operations generally can be referred to as CRUD operations, which is an acronym for all the things that you could do with a database using SQL. And I put an asterisk on here because this is the kind of term that's not related specifically to SQL. This is how you talk about the operations in an application. And there's only 4 of them in no matter what application we're talking about. I've mentioned this a few times already, but I'm going to put this on here as almost like a task list that we're going to step through, right? So there's a create, read, update, and delete, CRUD, CRUD. And we're going to now write all of these operations into our program ourselves. So we're going to go through these one at a time and create them ourselves from the code using Django. We're going to start with read, but the idea here is that any of the things that we make here are going to be interacting with SQL at some point, but we're going to do it through our backend framework. And we're going to start again. We're going to start with a read so that we have something to look at, but we have to start by making our database to do that, right? But this is something we're going to be very intimately familiar with. And when I say that it's everything in every application, this is true for, again, Airbnb or Wikipedia. Making an article is creating, and we go to the site, you're reading an article from there. If you want to make changes to it, that's updating it. And again, if you take something down, that's deleting it. That's all you could do with any application that you have, right? So we're gonna work through these steps as we go, one at a time, and write them ourselves. And this is a real quick mention of what Django is doing in all of this and where Django fits into this whole process, right? So it's going to do our table interactions. It's going to do the things that create the table, and it's going to do the CRUD operations explicitly. We can explicitly define each of those CRUD operations from the web interface to the database. And that's what Django is going to help us with. And so I want to think about these in 2 separate things. And Michael, this kind of goes back to one of your questions earlier. So our table interactions, in terms of Django, we define what's called models, and we'll do that in the models.py that comes standard with it. We'll do that here shortly, but that's how we talk about in this term is defining models. But models are tables, right? The models we define, think of them as tables. We have to register those models. This is all through Django. We have to do what's called make migrations. That takes our model written in Python, which it's just going to be a Python class. We're going to write this class. This migrations that Django does is going to turn it into something that can become SQL. This is part of the thing that it does. Is one of the commands we're going to do. This process that we go through when we make our database structure in our applications. We define a model, we register that model, we make migrations, and then we migrate. This is a step we did before when we made our super user. We just jump straight to migrate because there's migrations that come standard, and all these other parts are done by Django for the super user. But we're going to go through these ourselves and write them from the very bottom, defining our models, registering, making migrations, and then migrating themselves. And that is a separate process, but relevant too, because you have to do this first. You have to create your database tables and have those ready to go before you can have ways to interact with your database, right? Before you do your CRUD operations. But Django also helps us with that. So we're going to go through this process over and over again. We've done it already a couple of times, but this is similarly a 4-step process. We're going to write a view. We're going to map a URL. We're going to make or edit some sort of template. And then we're going to add navigation to make sure that we can get to our new URL, whatever that URL is. All right, so this 4-step process is going to be in the CRUD operations bucket, the table interactions, the defining model, registering, making migrations, and migrate. We're not going to do that a lot. So, Michael, to your question earlier, this is the kind of thing that you do not want to make a ton of changes on. It's easy to do. I'll show you how. You can make changes in the same way that we do it today. It's very simple, but beware. It can very easily cause conflicts. I'll call out some moments on how to avoid conflicts, but it's best to seriously measure like 3 times in your design and cut once when you come to this part of it and actually writing the code and writing the models and registering them and going through the steps we're going to go through today. That should be the last thing you do in your design process. Any questions about this? All right. So we are going to, after talking about how we must be very, very careful with our design, we're going to, like always, fly through our design portion and go basically straight into writing the code. But our application is very simple in what we're going to do. So let's start by going. I was flipping through everybody's homework to see who was catching up. I'm watching you. No, I'm joking, but I am. It's not a joke. So we're going to go into just our consoles at first and get started the way we always start every day, which is, who can remind me as I go there? What's the very first thing we got to do every day we start?
Do we go into our console?
Yep. Yeah, but I gave you that one, man. That's a dodge. Come on. What do we do from here? What's the next step? I guess step two. Once I'm in my console, then what? What am I doing here?
We're like uh oh man, I got nothing.
Oh man. Okay. It is we start our virtual environment. Step one every time. So we're gonna do in our home directory in the tilde directory. We're just gonna do source and then whoop the name of our virtual environment. In my case, VM named after the package we used. Bin and then activate. And really keep in mind as you're doing this, use tab complete. Hit the tab key to make sure you're in the right place. Because if you start typing the name of your virtual environment, hit tab, and it doesn't complete, you might be in the wrong place. You might have to CD to get to where you need to be. So I'm going to turn this on. I can tell we've got our parentheses going with the name of our virtual environment inside of it next to our tilde. And now I'm going to change directory into the root project directory. Good God, I have a typing impediment with the word clear. Okay, so now we're ready to start on what it is we're going to do. And before we go real far into this, let's have a look at the structure we've got now. I'm going to do our tree command because we're going to go through it a couple of times. I'm going to do the A flag. So tree, lowercase dash, or space dash A, also lowercase, space dash uppercase I. I'm going to open a string so I can put whatever patterns in here I want to ignore. So I'm going to put 2 underscores, ignore my PyCache stuff, except I will spell PyCache correctly. There we go. 2 underscores afterwards, vertical bar to do or, and pass any other patterns I want to ignore. I know for a fact I want to ignore my anything as JS, CSS, and IMG that comes with the admin stuff. Otherwise, this tree is going to be gigantic. And this, again, is all these things I'm ignoring are pretty specific to this project. Those are not like universal ignore things. If you run this same command one level up in your home directory, it's going to give you this gigantically huge tree because it's going to include your virtual environment and stuff like that. But all right, so when we run this, it should have a good output of our project structure up to now. So here's the dot, which we're using to reference the directory we're in. I left it as such. It's this tilde slash my site. Keep that in mind. Dot, we'll use that again today a couple of times as we reference files that we're going to use several times. Here's our db.sqlite SQLite 3. That's the database again that I mentioned. That's good for development, not for production, but it is the SQL database that we talked about. Last time we ended up doing our static directories where we made our to-do level. Sorry, there's the application level, and it copied up to the project level. We made static to-do scripts. And then it copied up here as well. Static, and then the name of the application, and then the separate scripts. So we're going to do a similar thing today with some templates and stuff. But today we're going to be messing with and starting with our models. This is something that comes standard. So again, the process that we're going to follow today when we define our databases, we're going to start in models, and then we write a model or several models that will be, again, referencing, that will be defining the tables in our database eventually. And then this admin.py is a way for us to see it in our admin panel, which is going to be good. So we're going to register in our admin panel, and then we have to come back here to the console to run the next 2 steps of this 4-step process. So let's go look at our website. I'm going to open up a web tab, see where we are now. So we're going to build on this. If you recall last time, we just have our homepage that we were calling index, and we've got some GIF stuff going on and a couple of navigation bars here, a couple of navigation elements in our navigation bar. And we hooked up our delete confirmation to our about page just to test it out. And so this is roughly where we should be now. What we're going to do today is we're going to add our to-do list application in a similar pattern to what we've done up here already. This could be very easily just a single page. You come to your to-do app and that's it. But we're, again, for demonstrative purposes on where these things go, how you can make several apps on one website and use Django to do it, and how this can be structured, we're going to add another item under here called to-do that will go to our to-do page. So we have to build that page, build that navigation. That's kind of the goal that we're going to get to. So let's start in the models.py, and we'll go up to our files. We'll open up our files this time. And we're going to go into my site, to do, models.py. And we are going to start defining our models. All right, so this is what comes standard in your Django projects and applications. This is an application level. So we're in the application level right now. We're in our to-do list application. And at this point, before we come and write again, we would have gone through the exercise of defining our databases and what they're going to be. In our case, they're going to be very simple. We're going to have a task item, and the task, that could be the table. The task is going to have a title, it's going to have a due date, and it's going to have some sort of status that we could toggle complete or in progress or whatever statuses we want to add. So those are the three things we're going to have. And again, this could be any number of things. This could be have assignees in it. This could have any number of other things. It could have like Gantt charts and all kind. You can go crazy with this, but we're just going to use three example sort of columns in our database, if we think of it as a table, to get this going. This could be added in the same fashion. And what we're going to do is we're going to define a class that is going to have those columns as attributes. So just in Python, the way we had before, I'm going to go down here where it says create your models here. I'm going to take that out because we don't need it. We can create our models where we like. You don't have to tell me my business. And you can ignore this error right here. It's just saying that we're importing a package and not using it, but we're about to use it. It's this models package, and we're definitely going to use it, and I'll show you where. All right, so what we're going to do is we're going to define a class the way we have in the past, and we do that by just writing the word class, lowercase. Make sure we zoom in a little bit. And then space. And then the naming convention, just to refresh your memory, is capitalize the first letter. So we're going to call this a task. And this time, we're going to have open and close parentheses before our colons ended up. And on the inside of this, unlike the classes that we made on our own, we're going to inherit something. We're going to put something in here that leverages, again, this idea of inheritance. So what this does is it takes from another class some other place and grabs those attributes and methods that class has and automatically kind of loads it to this as a starting point for this class. So we can use all the things that this other class does in our class without having to explicitly write it down. And that's called inheritance. And this is something that Python does through classes. So we're going to do the models, which is the package up here that we imported, dot capital model. So what is this capital? What do you think this thing is here? Like what data type in Python do we think this is?
That's going to be the function of the class.
No. And that'll be a method. But no, think about the naming conventions.
It's another class.
It's another class, exactly. So this is a class written down someplace. If you went to this is in the Django, documentation in the actual Django code itself. This is probably a directory. This Django.db, import models. That's probably again the file name, and in that file name models, it probably has this model class defined. You go read exactly what it is. But when we do this right here, we're taking all that information, whatever's written in that model class, wherever it's written, and we're telling this interpreter when it gets to this part right here, go find that stuff because we imported this into our environment. We imported Django in our environment, so go get the stuff from Django. And then when it gets here, it says, all right, now use that stuff for our class.
We're inheriting from models.
We're inheriting from model. Yep. And now we're going to set some attributes that we discussed. So we're going to give it a title, we're going to give it a due date, and we're going to give it some statuses. Now, if you're following the documentation, I'm going to skip one step there and kind of loop back to it, but there's a method to this. The first thing we're going to do is define attributes. Again, think of these as the columns in our table. This task right here is the table name itself. So we're going to define an attribute called title, which is just like a variable when it's outside of a class, but inside of a class is an attribute. So we just do the name that we want to use in lowercase, and then we'll set it using the equal sign. That's is. So it's the title is, and then we'll do models dot, and we're going to do something called a character field. So models dot capital CHAR capital FILD. So character field. This is now what we will have if you imagine a form on our site where someone is going to go into and write in the title. We're expecting a title to be characters. So this is going to be a string, right? This is how we think of this setting aside this information is like, okay, this is going to be a string. This character field requires a keyword argument called max length that we have to set whenever we set it. Now, this is a number of characters that and this can be used in all kinds of ways. But what it's going to do is set aside some space in the database that's a strict limit for this. So the title of a task, honestly, we could probably get away with like 30 characters. I'm going to do 100 for this example because that's more than enough. But if you have some reason to set this smaller, like if you're doing states and you know it's going to be a 2-letter abbreviation, you could put 2, and it'll restrict it to just that number of characters. So this is one way that you can restrict the information that goes in your database in a fairly simple way. But max length is required for character fields. So that's it. Then we've defined how the title is going to be stored in our database. We've defined that as one of the attributes that it has. Now we're going to give it a due date. I'm just going to call that due. So, just the word due, because I know that's a date. But we're going to use models, once again, dot date field. And this doesn't take any required arguments of any kind. There's all kinds of stuff that could be done with it. We're going to leave it as the default for now, but I definitely encourage you to look into what can be done with date field, what could be set. Lots of really cool built-in things. But this will give us the ability to just handle dates, and we don't have to write anything further, which is really awesome, actually, because dates are kind of a pain. All right, so the last attribute that we want to set for this is a status, right? Some sort of to-do or complete or whatever the case may be. And those are really the two that we're going to set for this example. But I'm going to show how to do something that has multiple choices, because there's a bunch of different ways to go. Similarly, it's going to be an attribute. And before we go any further, I really want to highlight that a bunch of the steps that we do as we build from this point on are going to be just choices. They're going to set us up for expansion later, or that's the way that it just seems comfortable to do it, or it's so that I can demonstrate something specifically, or because it's something we have to do because that's what Django says we got to do, right? So it's any number of reasons, and I'll try to make clear what those are. But if you have a question along the way, if you're like, why in the hell do we do it that way? What is this saying exactly? Stop and ask, because that's more important than getting through absolutely every step of this, right? So don't hesitate to stop me. All right, so what we're going to do is we're going to set a number of choices that we're going to be able to set for our status, right? So we're going to use models again. So we do models dot, and we're going to use a character field once again. So the same that we used up above, capital CHAR, capital field, FIELD. Similarly, we need a max length. This once again can be anything arbitrary. 30 will be plenty for what we're going to do. And we're going to add some more options this time. So this time, what we can do is set this keyword called choices. Make sure you make it plural. Don't forget the S. This is going to be a consistent issue for us throughout. Sometimes it's logical to have one. Sometimes it's logical to have plural. Try to follow logic when you name things. Choices is the required. If you miss the S, it'll break. And what we could do here is we could set this to a number of things. Like we could just give it a couple of options. And at the scale of project that we're doing here, that's likely what we would do. But I'm going to set us up for something that can expand larger, because even if you do something just a little bit more complex than the to-do list we're going to do in class, you're going to want to set this aside to something else, right? So if you want to add even 1 or 2 more choices, then we do this and we want to keep this a to-do list, you're going to want to expand this to something else. So we're going to start by just setting ourselves up for that now and expand this to another place. So we're going to call choices as a variable name that we haven't set the variable. We'll go back and set the variable in a second, but we're going to set it to statuses. And this is going to be all caps because it's a constant. Now remember, Python doesn't have constants technically. It's all variables for Python, but this is for humans to realize that we should treat that like a constant, something that's not going to be changing throughout our code. And the last thing we're going to set here is a default, which is a very handy keyword to use. We're going to set it to a value that we expect to be in our choices, in our statuses, that we're going to go set up here in a second. So I'm going to set it to just the string to do, 2 words capitalized, space in between it, just like you would write it normally, just to do. And this is going to fill in by default that as our status. So every time we make a new status, it'll default to do. But this default tag is really helpful when we go to make changes to this database, because what we just did here is we defined our database table and we defined the columns that go into it. But let's say, like I said, you want to get to the end of this class, you just want to expand this, and you want to add like an assignee or something like that. You want to add a new attribute to this. You can absolutely do that, but it may require you to put a default because there will be records in your database that don't have that attribute. And for these relational databases to work, they all have to have the same number of columns. And so it'll need information to put in there by default to fill in the ones you already have. And default is the one to do that. So there are a couple of uses of this keyword. A very, very useful thing to do. Any questions about the structure of these so far before we step into making the statuses? It's all pretty straightforward so far. Right. Cool. So I'm going to move up just a little bit to just the underneath where we started defining the class, and we're going to make our statuses constant that will be used to reference down here in choices, right? And the reason we're doing this is so that we can have the two that we're going to use by, to enter in now. But then this is also something that can be extended, and we can make a lot more of them and create more statuses if we like from here. And this doesn't have to be done here. This could be done in a totally separate file. This could be done higher on the page outside of the class. There's all kinds of ways to approach this. So this is really just kind of a decision for me to show you that you could break it out of this call, and how to do it. Where we put it from there is kind of arbitrary. But it should come before this somehow. If we import it, it should be at the top, all that kind of stuff, right? So we're defining it for me on line 4 above our status attribute. And this can be one of two inputs, right? This could be a list, or I believe it could be a dictionary. We're going to use a list. And inside the list, we're going to have tuples. Now, this is not, again, very frequent that we're going to use these, but we're going to use them now. And we're going to put two values in this tuple. We're going to make two strings, and they're going to be separated by comma. The first string is going to be the status that we want to put first, right? So we're just going to say complete, comma, and that is what is stored on the database side, right? So this is what's stored in the database as one of the labels for it, and then we have a human readable label that we put on this side, and we're just going to redundantly put complete. Now this pattern of repeating ourselves, it's viable, but I'm just going to call it out here. It's somewhat of a hack that I'm doing to make our references later a little bit simpler and easier to follow. But this is totally a viable way to do it. So don't think that I'm just completely making this up just for class. You could repeat your keys and tuples like this going forward, or your choices option. You could do it exactly like this, and that's totally fine. So the other one we need to put in here is the to do that we use as our default. So again, two strings that match each other, to do and to do. And again, the reason we have two of these is the first one is what the computer is going to use to label the actual thing and set aside the information in the database. And the second one is supposed to be the human readable label. But it'll be a lot easier for us to just call this later, and I don't want to be distracted by making sure that we get the right one. It's an opportunity for us to make a mistake that we don't need to put ourselves up for at this point, and writing it twice exactly the same way as a string is a completely viable option. So any questions about what we did here? We broke our status choices out into this constant as a list of tuples.
Yeah, I know you stated this earlier, that this statuses could be a function somewhere else.
Mm-hmm.
But is there a reason in this example why it's being called out ahead of the status equals models dot char field?
Yeah, absolutely. So that's something that if you don't define it before you call it, given the sequential control structure, this is going to be read top to bottom, left to right. It stands a chance of breaking, and it probably will break. So whatever you call down here needs to exist for the interpreter, or else once it gets here, it'll get confused. It'll be like, wait, what is this? So in this case, it comes here. If we wanted to put this, like, say, in another file, we would import that information up here in our import statements. And the reason imports always go at the top is for that same reason, is so that it doesn't break when it's referenced wherever it's referenced. Does that answer your question?
Yeah, I was looking at, I'm trying to understand. I'm building the structure. I kind of want my foundation set first. Then I would introduce my choices or my characters. And in this case here, part of the structure called it out, so you had to define it ahead of time.
Okay. And so, like, what I'm defining here is really a space for it to grow, I guess. And we talk about that, like this right here, moving it over here, like this, we could actually have just defined in line right here instead of using a variable of any kind. But the decision to move it up here is going to make it something where we can now add more than these two, and it'll be easier to maintain and read. But that itself, at some point, is going to get large here, and we're probably going to want to move it to a separate file. You see what I'm saying? So we've kind of taken a mid step on where the foundation is going to be set, and this is an example of, like you're saying, um, a place where we've decided to set it up this way so that it can expand to a certain point. Does that make sense?
It does. Thank you.
Cool. Right. Good questions though. Good comments and stuff too. All right. So before we move on from here, actually, you know what? I'm gonna do this a little bit different than we have in the past. Let's move on from here. We'll come back to this because in the past we finished writing a method for this, but this should work the way it is. When I hit save, it should get rid of that little warning. Shouldn't be any errors, and this is fine the way it is. This will work, um, the way that it's supposed to. Now, before I go register this model, I want to show what I'm talking about when I talk about register. Now we've defined this model. We need to go do the rest of this to set it up. Actually, write this out to our database and go through those other steps of the migrations that we talked about. But first, what I want to do is I'm going to go back to my site and I'm going to go to the admin panel. So if you recall, if we do /admin on top of our root domain, it should take us here. And oh man, let's see if I remember my actual admin login name. Don't look at my secret code. Is that it? That's it. Nice. Okay, cool. First guess. All right. So if we recall this, and if you don't remember, if you forget that step, and again, the easy save, and what I would have done now if I didn't remember it, is go back to your console and just create another super user, go through those steps, just takes a couple of seconds, and it'll get you to here, and you can reset your passwords, get rid of super users, whatever you want to do. But the reason I want to show this is the admin panel, right? We've done this before. We've looked at this before. We did this when we set up our front end stuff. But what we're going to do is when we register our own models, we should be able to interact with them here, and it'll pop up here. So that's kind of the idea is what we're going to do. We don't have it now. We're going to register them and have it pop up. So what we're going to do is we're going to go over to back in our file system. We're going to go up to our to-do application level and the admin.py. So we're at my site to do admin.py. And this is where we're going to register the model, where it says register your models here. Before we do that, we have to import them. So we have to from dot, again, that's the directory we're in. So in our case, my site to do, because we're pulling this in from the models file. So we do from dot models, import, and then the name of the class that we defined. Task. We could put an asterisk here and just import everything. This is not a best practice. This will work, but it can cause collisions. So we explicitly pull in the class by name that we want to do, capitalize. If we want to do more than one, we can comma separate them. No trailing commas on this one, though, just the name for the one thing that we got. All right, now it says register models here. Again, don't tell me my business. Underneath that, we're going to add a simple line for every model that we wrote. We only wrote one model, our task model, but every model that we write in our project that we want to see on the admin side, we're going to do admin.site.register, and these are built-in methods. And then we'll do the name of our class, which again is referenced to a database table. So we're going to do admin.site.register and then task in parentheses. I'm going to save this. And that's it. Now, when we do that, what should happen is I go back to the admin panel. If I refresh, I might have to reload the server side. Let's see if this works. So this should work to where it pops up on the admin panel and we can see something there, even though it's not really going to get to a database yet because we haven't made the database. There we go. So now we have the thing that we defined is here, right? So if we click on this, though, it's going to say womp womp. That doesn't work. No such table to do task, right? So we got to go make this table. We got to finish this off. And I'm going to try doing something and see if we need to run the migration twice. It'll be a learning experience for both of us. Normally, I've done this other step before we go here, but what we're going to do is we're going to finish up this migration, and then we'll go back and adjust the class as we need to. So the last step we need to do to get this to work, or the last two steps, is we need to go make our migrations, which is going to boil this down into the next step closer to SQL, and then we're going to migrate it. That's going to actually write our class definition into the database as a database table with the columns that we defined, right? So we're going to go through that process in our bash console. Back in the bash console, I'm going to get rid of this stuff, get rid of that stuff, And we are going to do, very simply, the command Python 3 manage.py using tab complete to make sure that we're in the right spot. And then we're going to do make migrations, plural, because there may be more than one. And when I hit enter on that, it's going to say migrations for to do. It's going to say which app has migrations and which ones that it made it for. And then it'll say what it did. And the first one that you always make is going to be serialized 00001 underscore initial. That's relevant sometimes when you have to manipulate these things. There's a ton of stuff that could be done with migrations when you start doing this. But what we've done here is just set this up. So we have set up our migrations. If we go back to our to-do directory, we can see a migrations directory here next to our static directory. And if we go inside, we can see that file is right here. We're never going to edit this file, but I'm going to pop it open and have a look. And this is yet another class. Like there's more classes. They have a migrations class. And some of the stuff is the things that we define. There's the name that we put in their task. There's some other stuff in here. There's our title and due date and all that stuff, right? So what's happened here is that Django has taken what we wrote and packaged it up in one way as an intermediate step for us to come in here and look at it and make sure it's doing the stuff we need it to do, right? So there's one of the places that we can look when we're debugging things if it breaks or doesn't work, right? Once we make migrations, this is what it's making. So we can come in here and have a look at it, figure out what's going on. And each time we make one, it'll make a file with a serial number and a name that we can look through and we can roll back in time if we need to. So once we've done that, once we made these migrations, the next step is once we're satisfied and we're like, perfect, we got our model definitions laid out. We've now made our migration. We're ready to rock. Let's migrate this thing. So we're going to do Python 3 manage.py migrate. And there we go. And it'll say applying migrations, and the little green OK gives you the warm and fuzzy that you actually did it. And so now if we come back here, I don't know if we need to reload. Let's start refreshing. I'm going to my task, and now it works. We didn't have to reload on the server side. So now we have an actual interface with the database that we created. So now we can add tasks up here, and we could use all the stuff that's built into Django's admin interface to do those CRUD operations we're talking about. So we make a new task. We have this due date that defaults to dates. There's a date picker, right, which is pretty cool. And then our to-do list, our statuses come down as drop downs. So we can do complete to do, but it defaulted to do, just like we told it to. So this is what we defined in the class. And what we did with the migrate is to actually tell the database to set this stuff aside, set it up so we can save it. So when I hit save, we should save it. But now we got this thing that just says task object 1. That sucks. But this works. So what we're going to do is we're going to change that to something we can read. But does everybody understand what we did up to now? Are people able to do this so far? All right. Seeing one nod, seeing a thumbs up. Nice.
Working
Cool.
fine.
Excellent. So what we're going to do is we're going to change this in a way that makes this a little bit more readable using Python classes. Why did I just close the thing that I need? So I'm going to open my files up again because I closed it for some odd reason. Go back to my directories, and we're going to go to my site, and we're going to go back to our classes or our model definitions. So we're going to go to do models.py. And in our task definition, we skip the step. It's in the documentation, but I skipped down because I wanted to show you what it looks like when you don't do this step. So we just, if you're following the documentation top to bottom, you would have done this before we registered the model and all that stuff. I'm going back to show you this is what comes out by default. It just says task object, and then it gives you a number. That's useless. So what we're going to do is down in here, like we did in our own classes, we're going to define a method that will give us some information that's human readable, that we can see it in that admin panel and other places that's going to be useful for us, right? So what we're going to do is, you call our methods are functions. They look like functions, but they're in classes, so they're methods. So we do def, D-E-F, and then we're going to do double underscore, str, short for string, and double underscore. And then we're going to pass our self, like we do with methods, because the default is self-referential to an instance of this class. And we're going to very simply, just like we did with our example before, we're going to return a formatted string that is going to have some information from this, like say the title and the due date should be good. So we're going to pass curly brackets, and we can do self dot name of attribute we want inside curly brackets, and then any other string that we like. We can put commas in here to separate the two. We can put a colon, we can put a dash, a vertical bar, whatever you like. It's a string. So anything that works should be acceptable. Try stuff out. But keep in mind that you're going to be reading this later, so make it useful for you. Or make it useful for people in the admin panel. All right, so once we save this, refresh server-side code. I'm not sure if we need to migrate this because we didn't change anything in the table. This is just thing out. So what I'm going to do is I'm going to try just saving it, reloading the server side, and looking at the admin panel and see what it does, and see if it changes it. If it doesn't, oh yeah, there we go, it changes. So we don't have to migrate on that, right? So that was actually something I wasn't sure about. I thought maybe we'd have to run another migration. But because we didn't change any of these attributes, because we didn't change any of the database structure itself, we didn't have to run through the migrations. This is just changing something that's on the admin side. So we should be fine on this. But if it breaks on us horribly later, we might know why. Let's try adding another task and see if it works. But any questions on that? On how we added that string so that we had something more human readable on this side? Oh, it still works. Questions on this? Nothing. Right. So this right here is how you define your database. This is, again, once you've designed it through the process we talked about at the beginning of class, you've come up with your schema, you've normalized the database as best you can, and you've defined exactly what you're going to do. You come in here and write this out by these definitions, and you define exactly how things are going to go in the database by, you know, how much space they're going to take up, what each thing is going to be handled as, dates, numbers, whatever the case may be. Create a migration, check it, migrate it, make any changes you need to for the admin panel. Now, what we will do as developers is we will need to make a way for people to interact with our database like we can here. So this right here, you might be thinking, well, this is CRUD operations. This is what we're talking about, right? This is not something you're going to give to end users. We've mentioned this before for super users. This is, again, if you're, it's like, say you're working at a company, there may be a handful of site administrators that have access to this. And this is what you'll be writing this piece for. So any of the adjustments you would make here, you can like change everything on this to make it white label to a particular company or change the layout and all that. Like all this stuff is customizable. This is just what it looks like out of the box. But this isn't something you're going to give to end users of your site typically, right? If you're making something that people are going to go to, this isn't the place they're going to go. You're not going to give very many people access to this. So what we need to do is we need to write these same operations, this way that they can click on these things and make these changes and go to a forum and do the stuff that we can do on this. We need to do that same set of interactions on our site so that people can actually do it to make a to-do list. But we're basically going to do the same thing. We're going to have this kind of table with a list of each item in it that we can read and we can interact with, create, update, and do all the CRUD operations. So this is sort of a model of what we're going to build. We're going to rebuild this on our own site. And that's the next piece of the backend interactions. Any questions on what our goal is here or what we've done up to now or anything that's come up so far? All right. So as we switch gears into this is another 4-step process. We're not going to go through this writing models, setting them up in the admin panel, you know, creating migrations and then running a migration. I definitely encourage you to go through that process a few times to cement it home. This next process we're going to go through, we've already done a few times, and we're going to just keep doing it. So we're going to write a view, we're going to map a URL, do something with a template, add navigation. It's going to be that same 4 steps for each of these CRUD operations. The first one we're going to do is read. So we can get a way to get these tasks that I've created here visible on our site and just set that space up. So if we think about the designing a building analogy, think about this as like we're just going to set aside this is where you can come in and see our list of objects, our list of tasks. This is like the office where these things exist. It's off the lobby. We got to turn into one room to get to it. But once you go in that room, you can see all of them and just see a big list of them, right? So we're going to list out just like this page we're doing here. So to do that, go back into our to-do application level directory. So we're my site to-do. We're going to go to views.py. So we start by writing a view. And we're going to write a view very similar to what we've done with these. We're going to use a lot of the same patterns, except this time we have to get some information out of the database first, right? So we have information in our database. We're going to retrieve it and present it to our page. So that's the goal of the view that we're going to write. I'm going to go down below this about view, and we're going to continue to write functional views. Next week, we'll refactor these into classes, but we're going to keep writing these as functions. So we're going to follow the same pattern we have. And this one we're going to call, we're going to use def again, like we have. We're going to call view tasks, view underscore tasks, plural, because we could view one task in a detail level, or we could view several tasks. This is viewing tasks, a whole list of them. And we're going to handle, just like we have before, a request. Whoa, except we'll spell request properly. Inside parentheses, and then colon tells the Python interpreter to expect an indented block. We're one indentation down, and we're going to define a variable called tasks. And this is going to hold the information from our database. So what we're going to do with this line of code on line 11 for me, we're going to write what is going to boil down into SQL. So we want to think about that from, you know, from which table, right? What we want, what information we want, the three pieces that we want, where the data meets these criteria. So we're going to say which table we're going to start with. It's slightly out of order of the SQL, but it's going to have the components, right? So task is the name of the table that we want to use. We want to get stuff from the task table. So we say task dot objects. So all the objects in the task table, or of the objects in the task table. So this is what from which table. So from, which table, right? And we're going to say where. This is the where part. We're going to say all of them and get their values. Now we could put filters. We could put different things in here. We're just going to grab them all for this example. But this is where those things would go. So this is where you would think about what information you want out of your database, how your schema works, and how you reference exactly the records that you want to store into your object here and then do something with. Right? So this statement here is how we get stuff out of the database. So we reference the name of the table, then we tell it that we want to get the objects out of the table, and then we do whatever it is we want to do to them. We can grab some of them, we can grab all of them. In this case, we're going to grab all of them, we're going to store it in a variable tasks. And now all we want to do with this is we're just going to read all of them. We're not going to do any filtering. We're not going to do any manipulation to them of any kind. But if we wanted to, this would be a place we would do it. For our purposes, we're just going to send to our front end a context object. This is a standard name, so we're going to use the word context several times throughout this, and it's expecting a dictionary. So dictionary is going to be curly brackets. It's going to have key value pairs inside of it. So the key is arbitrary. We can call it whatever we like, but I'm going to call it the same name as the variable name we used above, tasks, because this is what we're going to reference later in our front end, in our template, to make sure that we grab the information out of our tasks and present it to the screen. And the value of this key value pair is going to be that variable itself, which again is a collection of the objects from our database. So we grabbed all the things out of the database in line 11, and then we put them into this context object in line 12 in this key value pair named tasks, so we can reference it later. Now, since, again, we're not doing anything further, we don't have to have any more code in here except to return something to us, and we're going to follow a lot of the same pattern we did above. We're going to do return. We're going to use render once again. Here, let me get up a little bit from the bottom of the page so it might be hopefully easier for you all to read. So we do return, render, open parentheses. We're past the request again because we need some information from it, just like we have in the past. We're going to tell it which template to use, like we have in the past, except this time it's going to be to do / view - tasks.html. Mind your pluralization of things. We haven't made this yet. We're going to make, similar to our static files, we're going to make a templates that are specific, template directory that's specific to our application. And then the last piece we need to send to our render call is the context object. And that'll make sure that we get our task list that we pulled from our database to the front end so we can present it on the page. And that's how we're doing that. So this right here is the fully formed read operation in Django and in CRUD, or the R in CRUD, put it that way. So I'm going to save this. Oh, we got a little warning. What's this warning? Undefined name task. What did we forget to do? What does this mean? Anybody? What is this saying? This is saying undefined name task. And what is this referring to?
Hmm. Is it, does it need to be plural?
No, no. What is this referring to? Where do we write this? We wrote this, right? We wrote a task. We defined this ourselves. Where do we write it?
We create
Uh,
that in to do
We created it in, it's in the to do directory, yeah. Which file do we write it in?
it's in the models file?
It's in the models.py file. So what do we have to do to get into this file?
reference models
Yep, we got to import it. So
import.
we didn't import our class, right? So from, just like we did before, dot models, import, and then again the name specifically and explicitly of the model that we want to pull in, not the asterisk, even though that will technically work. When I save that, that flag goes away because now we've referenced it properly. Following the convention, putting our imports at the top. All right. Now we have done this view task. Next step is what? Define a view. Now what?
We need to create that view tasks.
Not yet, but close.
Uh,
We need to map our URL. Arguably we could go to that next, but I want us to go through mapping a URL first.
okay.
So we write a view. Now we're going to map our URL. So again, we're going to do another addition to our URL patterns list, which is going to be another path. And this is going to be, we'll just call it to do, arbitrary name, trailing slash is important, comma, then the name of the view that we just wrote. So views dot view underscore tasks, plural, comma, and then the name that we want to use as a reference. We will also use view tasks to keep it consistent, but by convention, we're going to use a dash, not an underscore, but you can really use whatever you like. Just make sure that this is consistently referenced later when we reference the name of things from our template when we go and update that. And this has to reference the name of the view that you wrote, which follows the Python convention of underscores in the function names. And this dash is kind of a convention too, but consistency is more important on reference to these things. So we're going to add this with a trailing comma just because that's a good habit. It won't break anything in a list. And then we can save it. So we add this pattern, just another path to our URLs. And now what do we need to do? John Michael, that's the thing you said before this, was we have to go make the file, right? We have to make our view tasks.
Yep.
Cool. So in the documentation, I think it says to do this in the console. I did it in the console last time. I'm going to do it in the GUI this time just to switch it up, and then we get a difference of ways of doing it. Think of this like the workout thing. You can go the fast way or the slow way. We're going to go the little bit slower way. We'll step through it in the GUI. You're welcome to do the commands in the console. But what we're going to do here is we're going to make a templates directory, and then inside that templates directory, just like we did with our static files, we're going to make a redundantly named to do directory inside to do. So it's going to be to do templates to do. And the reason for this is to prevent future conflicts. So I'm in my to do directory now. I'm going to go up here to the top where it says directories, and just the name, I'm right here where it says enter new directory name, I'm going to write lowercase templates. If you recall, we set this in our settings.py, so don't get creative here. Call it templates, or else this won't work. I'm going to hit new directory. It'll take me into that directory, in theory. I guess I should have hit that earlier because I didn't realize it was going to take that long to think about it. All right, now I'm inside my to-do templates directory. I'm going to make another to-do directory. This, again, is to ensure that we do not have conflicts between this templates directory and others. And now I'm in the to-do templates to-do, and I'm going to go to the files section, and I'm going to make the view tasks dash tasks.html, and this has to match what we called in our views.py in the function. Take us to a blank page, and we are going to do what we have in the past with extending our base template. So we use the Django tag, the curly brackets, percentage sign, and I'm just going to put percentage sign, curly brackets right in between it. The word extends with an S, and then the name of the template that we want to extend as a string, so base.html. And then another set of Django tags we're going to do our block tag, which is a reserved word, and we named our block content just for ease and remember so we don't have to go double check. And then we have to remember to end our block. All right, now we're starting with a fresh template. This is a starting point for a template. I'm going to save that before we move on, but we're going to add some HTML in here and we're going to show how to set this up in a way that we make a table and then go and grab the information out of the database and populate that table with each row from the database as another row in our table. So we're going to define the table space and make the headers on it, and then we're going to fill it in with Django to do the rows. All right, so the way we're going to do this, we're going to have, I'll move over just a little bit for human readability. I'm using H3 tag. It's a header. It's the third level header, so it's not as big as the top level one. I'm just going to say tasks. So this will be at the top of the page, above our table. So we're going to put our table inside of a div like we've used before. And we're going to set this div to have a class of table dash responsive dash SM. And this is going to help it resize and move around and look nice. And it's going to be using our front end frameworks like we did last week. Again, building off of those things so we don't have to spend a ton of time setting it up to make it look nice. Inside of our div, we're going to use the actual table element. And we're going to give it a class of, oh, I'm sorry. These class calls have to be double quotation marks. Sorry. Got used to writing in Python, and I forgot that we're back in HTML. Got to use double quotation marks here. So our class, we're going to have table and table dash hover. So this is going to, again, just make it look nicer. Give us those little effects that when we hover over an element, it kind of grays and does some cool stuff. Again, leveraging frameworks so we don't have to do it ourselves. And then each part of this table we have to define in rows. So we're going to define a row. The first row is going to be our header row. So it's going to be a TR is the name of the tag, and then inside of it is going to have TH tags for table row and then table headers. So we're going to do the table row, so TR. We'll do opening and closing automatically, and this nesting is being done automatically by my thing. Again, it's for human readability. Inside of our TR, we're going to do a TH, and then inside of that, we'll just do the name that we want to use, right? So we're going to have title, we're going to have due date. And these are just arbitrary strings. We could put whatever we want. We could put due, we could put due date. Makes no difference at this point. This is just going to be the headers on our table and what they say. So this is going to say status. And that's all we need for that. Right. Now, what we need to do under this closing table row tag, imagine this is the header, the top row. We're going to make another row for each row that we have in our database. So what we need to do is now use Django to grab the stuff out of that tasks object that we made, that we passed to our context. Here, you know what? I'm going to just open up files. I'm trying to do this too long. I don't want to go over time, but I want to make sure that we're really clear on what we're referencing and where stuff is. Right? So what we're going to be doing here is we're going to be referencing that same thing that we defined in our view. This right here, this tasks. So we're going to grab all the tasks out of this and loop through it and present them all to the screen here. So we need to use a Django tag. So we need curly brackets, percentage sign. I'm going to do percentage sign, curly bracket. And this is just going to be an loop, a for loop, just like we've done in Python. So it's going to be for, and then an arbitrary variable name. So we're going to say task in, and then an iterable. Again, this iterable is coming from our views. It's what we named it here in the context object. We called it tasks. So here we will call it tasks. So for task in tasks. And we're going to do something in here. Now, before I do anything, I'm going to end this for loop in a Django tag. So another set of Django tags, and we do end for, all one word, all lowercase. If you forget that, it will definitely break. Don't forget your ending tags. Okay, so in our section here, what we're going to do is we're going to make another table row for each piece of data that's in there. And each piece of data should have a title, a due date, and a status. So we're going to need table data sections for each of those. Whoa, what is this? TD, sorry, table data section. And I'm going to go ahead and just copy this and paste it 2 more times because we're going to fill it in 2 more times, right? Now to dynamically grab the information from this task object that, again, we're inside of a Django for loop here, we're going to use double curly brackets, open and closing. So I'm going to open and close them now inside of our TD tag. And then we're going to reference it with dot notation. So task, the name of our variable name up here, dot whatever it is, the attribute name that we want to grab from that class. So this is basically, think of this as an instance of a class. We've instantiated the class, and now we're referencing it through dot notation to get its attribute name the way we have in the past. And so we're going to do that same thing with double curly brackets here for the other two attributes we want to grab. So task dot do is the name of the attribute there. Then double curly brackets task dot status. So that will give us our due date, title, status for everything we have in there. I'm going to save this because it shouldn't break, but it's good to have it to save. But we're not done yet, because when we look at this, one thing that we have to do constantly is think about what's called error handling. Think about what could go wrong or what scenarios might be possible, and deal with those as best you can when you first write your code, when you first design things. So feasibly, this could be, and the first time you come to a site, this is not going to have any tasks in it. So if we leave our code the way this is, it's just going to break, because it's going to go to look for the thing, and this is going to come back empty, and it's going to say, womp, well, we don't have any tasks. Sorry, no tasks, like it's empty and there's nothing. So what we want to do is have something presentable on the page that's not just empty, not just blank, and not just dead, and say, hey, there's nothing there. So we're going to use a simple if statement to check to see if this tasks object has stuff in it. If it does, it's going to do all this stuff. It's going to have the table and everything. And if it doesn't, it's just going to give us a message that says there are no tasks. Right? So we're going to take this entire table, this entire div that we got our class, that our entire table in. So right underneath the tasks header, and I'm going to put another Django tag right here. So curly bracket, percentage sign. I'm going to close it up so we don't forget. And then I'm going to do if, and then just word if tasks. So that'll return a Boolean of, if that's true, come in here and do all this stuff, right? So if there is something in tasks, it'll return true. If tasks is 0 and empty, it'll return false. And so we need to go down, all the way down, past the end of our table. We can go even beyond the end of the div, because we got the div out here on the top, right? So out here on the end of this div, we're going to do our else condition. So in a Django tag again, we're just going to write the word else, right? So the if condition is up here on row 7. And if tasks exists, do all that table that we just talked about. Otherwise, in our else condition, we're just going to do a paragraph that says no tasks found. So that tells us that we did query the database and everything worked the way it was supposed to, but there's nothing there. And then we have to crucially end this if. So underneath our paragraph, we're going to do another Django tag, curly brackets, end if, all one word, closing percentage sign, curly brackets. That should be right above the end block for the content. So this is now our template. All right, what is the last piece that we need out of our 4-step process? We've now written a view, we've mapped our URL, and we've created a template that we didn't have before. What do we need to do to make this all come together in our project? The last piece.
What was the last one? Like to close the end if, is
Yep.
it?
Yep. End if, yep, as a Django tag.
Okay.
See that? All right, so from there, the last thing we need to do is add navigation of some kind to be able to get to this new page that we've made, to get to the URL. Remember, if we're on our site, I guess I can go back to view site. We'll have a look. We have 2 links here in our navigation element. We're just going to add another one down here at the bottom to go to our new to-do site. And what it should do is when it goes to that view, it should land at this page and pull all of the stuff out according to our view and present those two objects that I made, those 2 tasks that I made from the back end. So we have to go make that link to get to here. So let's save this. Let's go to, actually, do we remember where are these links? Where is this navigation bar? Where do I need to go for this? We're in our project directory.
Is it in template?
It is. It's a template. Which template?
Um, in base?
Yes, very good. It's in the base because it's on every page, right? So everything that's on every page is going to be up at the base. So we're going to go up to the project level. So my site, we're going to go out of the application level. Excuse me. Let's go my site, templates, base.html. And then we're going to very simply add, following the same pattern. I'm going to get rid of this button delete because we don't need this anymore. But you can leave it if you want to on the about button. Entirely up to you. So I'm just going to add another A tag underneath this. So I'm going to do A class. You can copy and paste if you like. We're going to give it the same button class so that we have up top for consistency. And in href, which will be our Django tag inside of a string, so double quotations, and then we're going to have the curly brackets, percentage sign. I'm going to do percentage sign, curly brackets to close it up. And we're going to do URL like we have in the past, URL. And this should be view tasks, right? Close it up. And then we'll put, say, to-do list on there. All right, that should be good. We save it, reload the source code on the server side. And then in theory, if we've broken nothing, we should be able to come back here, reload this, and now we have that A tag here. Let's see what happens when we navigate to it. And so in my case, it pulled up both those tasks that I put in there and said, hey, these are the tasks that we have. So it did the read operation that we expected. It's got their due dates and their statuses. If I were to say, I'm going to go to my web tab and open up the admin panel separately because we don't have a way to delete these things yet. So I'm going to go back to my admin manually. I'm going to go back to tasks and I'm just going to delete these. We can bulk delete back here, which is pretty sweet. And it'll say, hey, you sure you want to do that? And I'll say, yeah, I'm sure. I'm reckless. So go back to this and then we'll test that no tasks found logic to make sure that it does serve up the way we want it to, and it doesn't break. So that is databases, or what we wanted to cover regarding databases, and the first of the CRUD operations, namely read, where we can pull stuff out of that database and present it to our page. Any questions about that? Anybody actually able to get there or stuck somewhere that we wanted to help get unstuck? Seeing
Everything was being followed all the way to the last changes, which I'll just go back through the video to update because I didn't get them.
okay. Do you mean these last ones right here on the base.html to add the navigation?
Correct. That and I think I might have messed up in the what was it? The to-do views list.
Oh, like in the views itself?
Yeah, I'm not sure I got that code laid out correctly.
Okay. We can help debug now if you like. Was anybody else able to get it done before we hop into that, if that's something we're doing? John Michael Lucci, were you able to do to this point?
I broke it and then I found what I broke in the error page, like the debug screen it gave me. So
Okay.
I'm good. I'm good to go.
You good? Nice.
Yeah,
Nice.
basically the same. Yeah.
Nice. Okay. Okay.
Thanks.
Good.
Thank you so
Nice.
much.
Yeah. Thank you. Yeah. All right. So then, yeah, Michael, man, if you want to, we could debug together, or if you're feeling like it's enough for tonight, we could drop and you could take a look at it with fresh eyes later. What are you feeling?
What I'm gonna do is I'm gonna go back through the video because I was writing code as you move forward, and I'm pretty sure I missed a few steps.
Okay. Okay.
If I go back through the video, I'm sure I'll catch it.
All right. All right. Cool. All
Yeah,
right, man.
I'll
We'll
be
reach out
on
if you got
it.
questions. Appreciate the engagement. And
Well,
You know,
you'll get questions from me on the what you call it site.
yeah, Discord. Yeah,
Yes, but I'm beginning to understand the flow and the layout.
cool.
Um, but my understanding also is the way we're writing this, the database is already preset.
Um, well, not really. So, like, what we did today was we set the database. We actually defined and
Oh,
made it.
okay.
That was the if we go down to the models, this is the definition of the database right here. Like, this is it. So,
So this import models already has a defined base for the database structure.
yeah, it has a lot of the interactions that you're going to need for a database so that we don't have to explicitly handle them.
Right. We're using that to
Mm-hmm.
create our own setup. Okay.
Exactly. We're using those set of tools to define our custom database for our own application.
Yeah. This helps us where we don't have to rewrite all this.
Exactly. Because if we had to go all the way down to the level of like handwriting SQL and making this convert to SQL it would take forever. So
Yes.
that's the idea.
All right. Great.
Great. All right. Thanks a lot. See you Thursday.
Yes. Thank you.
Yep.